Hello and welcome to the Diabatix Flexibility Series. I'm Reshmaa Selvakumar and I will be the host for your webinar today. I'm the application engineer at Diabatix, and today we will talk about the influence of the manufacturing settings on generative designs. So today we will go on a deep dive through the different manufacturing settings that can be included and how that influences the outcome of the performance of the designs. Over the last few years, additive manufacturing has become a widely popular technique, and today we will explore 3D printing versus CNC milling, which is a more conventional technique, which is much cheaper, uh, and compare that in terms of thermal performance to each other. The application that we will be studying today is the LED cooling application. We will be using the same design setup for both of them and only change the manufacturing settings. And after that, we will look at the post-processing and the results of these two settings. If you have any questions during the webinar or just in general, please feel free to ask these questions in the chat box below. I will answer them towards the end of this webinar, and I will make time to answer them at the end of the webinar. Without further ado, let's get started. I'm going to go to the platform and I will show you how to do all of the case setup. Then I will walk you through the libraries and the manufacturing settings, how to include them. And lastly, we will look at the post-process results and compare the two results to see which performs better. Let's go to the platform now. So now that we are on the platform, let's start the case for the manufacturing flexibility. The application that we're going to see today is LED cooling. And like I mentioned, the manufacturing types that we will look together is CNC milling and 3D printing. So let's start with adding a case, and I will walk you through doing this case setup very quickly and very efficiently in a short time. So let's just give this a name, and then we can choose the case type, which will be a design case because this is an optimization case, and that means it's a design case, and a simulation is always just a CFD simulation. So the first step in our case setup process is to upload a step file. We will click on this button to upload step, and then we will select the step file. We can now populate the case, and the software simply does some background checks to ensure that there's no issues with the geometry, there's no overlap of regions, there's no surface patches missing or boundaries that are not connected, etc. And then we will have the geometry on the platform. Now, as you can see here, the naming of the geometry itself is from the CAD tool. So let's set it up region by region. So the second step that we will be doing is including the boundary conditions. So let's start with the solid region first. Like as you can see, this is the solid region. I'm going to select the region type, which is solid. And now I can rename it. Let me call it housing. And then I'll be able to select materials from the material library. In this case, the material that we're using is a 7075 aluminium alloy. You can, of course, include any other type of materials on the software. I think we've told you previously as well, but it is possible to include your own materials on the software. So that's it for the solid region. Next, we can move on to the boundary. So the boundary itself is basically where your heat source is going to be. And we are going to model this as just a heated wall. So we will set that up now. So in boundary type, we choose heated wall. I can rename this as heat source perhaps. and then I can give the heating power. So in this case, it's about 400 watts. And with that, this boundary is also complete, and so is the solid region. So let's move on to the fluid region now. So as you can see with the fluid region, what you have is essentially all the area where the fluid will flow in this region. So you can see that there's some purple that is visible. That's probably from the design region. So I'm just going to hide it so it's very clear where the fluid is flowing. And now we can set this up. So this is fluid, of course. And then I can rename this as well quickly. In this case, we are going to use water as the coolant. So I'm going to use water at 293 Kelvin as the preferred coolant. There are no buoyancy or radiation related properties. In terms of the turbulence model itself, I'm going to go with K omega SST for this case. With that, the fluid region as a whole is set. The next thing would be to set up the inlet and the outlet. So to be clear in terms of where the inlet and outlet is, let's take a look at these two boundaries. So this is the inlet and this is the outlet. So we'll start with setting up the inlet first. The inlet itself, I'm going to choose a fixed flow rate inlet. And let me change the name here as well. So the inlet temperature is around 293 Kelvin. I made that choice even in the coolant. The mass flow rate in this case is about, I made a mistake there. The volumetric flow rate from our end is about 2.5 to the power minus 4. So that's what I'm including over here. So the volumetric flow rate is also done, and the inlet temperature is done. So with that, the inlet boundary conditions are set. Moving on to the outlet. This is just going to be a regular pressure outlet. Nothing major. I'm just going to rename this as outlet as well. So this boundary is also done. Now we can look at the design region. So I'm just making this visible again. And as you can see, this purple area is the design region. It's usually a sub-region in the coolant, in the fluid area, and it's smaller. And as you can already see here, it doesn't touch any of the other surfaces or boundaries. So we're going to set the design region up, and this is where our differences are going to be for the two manufacturability cases. So we'll start with setting up the design region. Select design. I'm going to leave the naming as is because of course this is the design region. And here for this particular case, we already named it, and as you can see here, it's a CNC milling case. I'm going to choose CNC as my manufacturing type. And then I will choose the manufacturing settings. And for the manufacturing settings, I'm going to go with CNC 1 mm along the y-axis. Then I will select the material. Again, here I will use the same material as my solid region. And then this part is also finished. So we've included all the geometry, we've included all the boundary conditions. And as you can see here on the screen, we've also finished including the design and setting up the design region. The last thing to do would be to include the objective and constraints. So because we are exploring manufacturing flexibility, I'm going to include a very simple objective and a very common objective, which is temperature minimization. So in every region or boundary, you have the option called add target at the bottom of the region settings. So for temperature minimization, I obviously want the temperature to be minimized along the heat source, which is why I've chosen this boundary. And here I will add a target and I will choose temperature minimization. So that has been placed, and as you can see, there's a target that has been set up over here. And now I can submit the case. I'm going to click on submit. the first step that the software does is it validates the geometry, it validates the case that we've set up to make sure there are no errors or no questions from our end. And then we have updated our software recently, and now you can control the amount of credits that you choose to submit your case with, because this will also control the speed of your design. I can choose to run using 200 credits, and I can submit this case as a detailed design, in which case this detailed design will be ready in 10 days. But if I were to slide the bar a little bit, and maybe, I don't want it so soon, it's okay for me to run it with maybe 100 credits, then as you can see, it will take about 13 days to finish this case. So this allows the ability for you to choose for complex cases more computational credits to finish the case faster, and also allocate your credits as you want to create more designs or more faster designs based on your wish. I'm just going to use 100 credits for this case and submit it as a detailed design. Now with this, we are finished with setting up the case for CNC milling, and now we have to set up the case for 3D printing. You might think that this is going to be a long and extensive process where we repeat all these steps all over again, but it's rather simple. What I'm going to do is simply duplicate the case. I will rename it 3D printing this time. I'll click yes. Now I have a new case. I will click on Start Setup on the right corner here. And now the only change that I'll have to make will be within the design region. So I'm going to click Region Design. I will remove the manufacturing settings. As you can see, I've removed the CNC setting over here, and now I will choose the 3D printing settings. So I will choose the manufacturing type, which is 3D printing now, and I will select the relevant manufacturing settings for this case. So for starters, I want to explain that for the 3D printing, you actually have different settings compared to the CNC milling. I will also show you that in a little moment, but for now, let's start with choosing the settings itself. We're going to go with a smaller RF min size, and we will go with 3D printing 0.05 mm. We will select that. As you can see, the material remains the same. The target, of course, is still in place in the heat source, which is the temperature minimization target. All the other values in inlet and outlet boundary conditions are all existent. So the entire case setup is just done with 2 or 3 clicks. So now we can submit the case. We'll wait for it to be validated. And then again, we can choose 100 credits for this case as well. And we can start running the case. Of course, as it takes about 13 days to finish, I have already finished or already run 2 cases before the webinar, and I'll walk you through the post-processing of both of them right now. Before we jump towards the post-processing side of things, I do want to show you the libraries so we can very quickly understand how manufacturing settings will be included, or you can include them on the library. So for each manufacturing type, you see that you have the opportunity to include their settings. And based on the manufacturing type, you will have different kinds of settings that you would like to include. For example, just to show you, for die casting, you have quite an extensive number of settings that you want to include, or that you have to include, which include the minimum feature size, the maximum feature size, the bending radius inside, the outer bending radius, the angle and the design height, etc., as well as the orientation. So that's for die casting. For CNC and 3D printing, it's fairly minimal settings that you'll have to include, but it's also very important to include them over here. So for our current case, what we've included is 3D printing and CNC milling. So let's start with 3D printing first. We included this particular setting. So it was 3D printing 0.05 mm. We've included just the minimal feature size. The optimizer automatically takes certain overhang and other features, other settings into consideration for additive manufacturing. But this is a special case that it takes into consideration only for additive manufacturing. So we just click save and it's done. Of course, when you want to include your own 3D printing settings, you can simply click on add 3D printing, give it a name and the minimal feature size, and you're set. Coming back to the library, the next thing that we're going to explore a little bit in detail is the CNC milling. Now, for CNC milling, the settings that I went for this particular webinar was CNC 1 mm along the y-axis. So I basically included a minimal feature size of 0.001 and also a delta of 0.01 and the orientation of along the y-axis. If you were to include this on your own, you simply click on add CNC, you'd give it a name, and then you would include the minimum feature size. So in our case, it was around 0.001, and then the delta as well, which would be 0.01. Sorry. And I'll also include the orientation, which was along the y-axis, and I can add CNC, and that will automatically make it available in the library for me. So this is how you include manufacturing settings. But when you come back to the library, I do want to say it is as simple for any of the libraries that you want to include, whether it's materials, whether it's fans, pumps, or manufacturing settings. It's fairly simple. You just have to click on the category, click on add material, or add whatever it is that you want to add to the library. As long as you have the properties of those properties that are required for those particular categories, you should be able to include them on in the libraries page. And of course, you can always customize it to your own standards. An important thing to mention here is we are very particular about security, and anything that you update in your library will not be reflected to everyone's library. In fact, that is particular to only your library. So don't worry about it. Go ahead and add whatever materials that you want to use. Let's go back to the projects and look into the post-processing of the LED cooling applications that we have, and also take a look at how the results compare. Let's start with the CNC milling case and look at the post-process results. So as you can see over here, we have a quick case summary on the platform. I can already see, for me, the preferred SI unit is Kelvin, but of course, if you want degrees Celsius or Fahrenheit, you can switch between the different SI units. For me, this is comfortable, and I can already see that the maximum temperature in the solid region is around 444 Kelvin, and at the heat source level it's around 444.63. So this is already an important value for me, and I will take note of it. There's also the pressure drop that you can see over here. It's around 78,000 Pascal. Then of course there's some other values, majorly our input values over here. If I want to, I can download the results and the design and take a much closer look, but I'm going to start with doing most of the post-processing on the platform. So let's take a look at the results chart. So with the Tmax for the housing, it's around 293.16, but this is just the region temperatures, and then this is the T min, and this is the T minimum. At the boundary, you see that you can see the temperature of the heat source, the outlet, and the inlet, what the maximum temperature is, and then the same for the T mean and T min. And you can also see the pressure loss as a plot as well uh, on these charts. Again, in this case, you can switch the SI units if you want, and it will automatically give you the differences in each of the regions and each of the boundaries. So that's a quick way to take a look at the different boundaries and the temperatures at these different boundaries. Uh, let's take a look at the 3D results now. So I'm just going to wait for it to load a little bit. Okay, so the first thing that I am curious about is, of course, the design. So I'm going to first take a look at how the design looks. So I just go to the design tab, which is under coolant. I click on the surface plot, and what I can do is I can hide all the others, and I'll have a good view of just the design. Now, maybe I can try to show the housing. Yes, but the problem is because this design is very much internal, we won't be able to see it very clearly. So what I'm going to do is I'm just going to show you how the design looks. Maybe we can choose a different color. I'm going to use maybe an orange for this so that it's clear. What I'm going to do is I'm also going to take a screenshot of this because I do have to show this to my colleagues internally, while I can, of course, show it to them via the platform, or they can check it via the platform. Sometimes we all know that it's important to make a report, so I'm just going to take a screenshot. I'll use a transparent background, CNC milling, LED design. So I'm going to download that so it's automatically available for me. And then maybe I will take a look at also the streamlines. I can just give it the blue color. Yeah, okay. So that's a very quick view of how the streamlines are. But for my report, honestly, if for creating it, what is most important is, of course, to take a look at the surface plots at the heat source level. So what I'm going to do is I'm going to see how the temperature is in the solid region, essentially. So I'm just going to show both of this, and I will change the color over here, and then I will choose the temperature so I can already see how that looks. I'm going to hide this. So yeah, as we can see, automatically it sets the software, sorry, the GUI sets the temperature legend as well, and this already gives me a very clear idea on how the temperatures are in this situation. And as you can see over here, I have since I've colored the design, it's very clear that that would be part of the design region. I'm also going to take a screenshot of this with the transparent background. So CNC milling, temperature, LED. So that's all set up. The other thing that I would like to take a quick look at is the coolant. So I'm just going to look at that very quickly. I'm going to hide everything else, so we will just be able to see only the coolant's surface plot. So over here you can see that the design becomes the fluid region cuts out the design region, and that makes sense. And you can see that it's it's pretty clear in how this region is set up. So very quickly, maybe we will look at the temperature over here as well for the fluid region. Yeah, and as you can see, even here, the hotter region is, of course, near where the heat source is. And I will also perhaps take a screenshot of this. CNC milling, fluid T, LED. So those are the important things that I need. Of course, I can look into other parameters that I would need for my report, but like we did in this case setup, our most important objective, or our only objective, was to minimize the temperature. So I just want to compare this to the 3D design and see how it looks. So let's go to the 3D design now. So I'm just going to go to LED cooling, which is the main project. I'm going to look at the 3D design. Again, we have the immediate summary for the 3D design as well. And already you can see that with 3D printing, uh, the temperatures are much better, because we saw previously it was around 444 or something, and here the T max is around 399 Kelvin. And so obviously it's much cooler with 3D printing. But we also see that that means a higher pressure drop. But for us, this was not constrained, or this was not something that we paid it, set as a constraint in the software. So it's okay, because the main focus for us is to minimize the temperature, and already we can tell that with 3D printing, it's performing a little bit better. Again, you can download the results and the design itself, and there's also the results charts that you can quickly compare. So region by region, and again, boundary by boundary as well. So you can take a look at that. But what I'm going to do first is take a look at the 3D case results for this case as well. So I'm just going to reset the camera here, and then we can take a look at the design for this case. So let's just look at the coolant, the design region. We'll hide everything else, and this is how the design looks. I'm going to color it in the same color that we had for the previous design, and here already you can see that it makes use of most of the design space, first of all, and secondly, we also see that the software is giving you more three-dimensional shapes as well, that kind of spread the flow in different regions. And you can see that over here, towards the heats, where the heat source is, you have more of these blocks. But I understand that it might not be very clear a design, or it's not something that we would think of drawing. Whereas with the CNC milling case, even though it was a little difficult to imagine drawing something like this, that it was still with familiar pins or fins. And here it has, the optimizer has much more freedom with 3D printing. It can really push the limits with additive manufacturing or 3D printing, but that's also the scope of generative design as a whole. So what it does is really reimagines how we design heat sinks today, and goes for filling in the region with shapes and structures that will still give us better results. So what I'm going to do is, because of this design being a little to a certain extent random, the first thing that I'm going to do after taking the screenshot is I'm going to take a look at how the fluid region looks, because that will already explain to us how the fluid flows within this LED heatsink. So let's first take a screenshot of this. I'm just going to use transparent background again. 3D printing, LED design. So yeah, that's, oh, I did not download that. 3D printing, LED design. Download. So the next thing that I'm going to take a look at, like I already mentioned, is the coolant. I want to go to the surface plot over here. I'm going to hide everything else so we can see how the fluid is likely to flow. All right. So inlet to outlet, what we can already tell is that the design really pushes to have the flow spread everywhere. So as you can see here with the how the random structures are, it really pushes the flow everywhere else. So let's do the same that we did previously and take a quick temperature contour plot as well. Yeah, so yeah, as you can see here, the maximum itself touches only about 400 Kelvin, whereas in the CNC case, it was almost 40 Kelvin more. 3D printing, 40 now let's also look at how the surface plot for the solid region looks. So I'm going to hide everything else now. Yeah, and then click on the surface plot and then go for the temperature. I think it might be interesting to maybe show this as well. Yeah, yeah. So that's pretty clear. So again, it's very clear that this one's performing much better. 3D printing. All right, so I have all the images that I need to put together in a very quick report. So I will use them, and I will also, have a look at the temperature charts and the case summary itself and include these values as well. I want to show you something really cool. So to compare the two results that we've just needed, of course, you'd want to see the case summary next to each other, and if the temperatures were next to each other, it would make more sense. So what you can do for that is, if you go back to the project, we want to compare the 3D design and the CNC design. So this is the first design that I need to compare. I can just click on Add to Comparison. Now for the 3D printing design, I just click on the three dots again and Add to Comparison. Now I can click on this tab over here called Two Cases in Comparison. And immediately you see that I have the temperatures and the pressures and everything on the same table. So here I can very clearly say that the Tmax difference is almost I think about 34 degrees of difference. So you can compare the two temperatures right here. When you look at the housing, the temperature is almost 34 degrees higher in the CNC case, which is our first case, and in the 3D printing case, we see a much lower temperature. And you can see the same for other values as well. So like the T mean, the minimum temperature in each of these different regions. And of course, you can look at the pressure, the flow rate, and heating power and things like that as well. You can take a very quick look on the table. But the more fun or the more prolific part of this comparison is that I can click on the charts tab over here, and immediately I have a comparison of the maximum, minimum, and mean temperatures with different colors over here. So the charts are available for each region, for the sub-regions, and for the boundaries. So you can make a quick comparison between these two cases by just adding it to comparison. Of course, if you have 3 or 4 cases, you have all the freedom to include more of these cases for results comparison. And then once you're finished taking in all the information that you wanted, and just finished comparing everything, you can simply go back to the projects, and it when you go into the project, you will have the tab still open, so you can keep it for as long as you want. You can keep this comparison open, but if it's not useful anymore, then you can just click the delete button over here, and the comparisons will be deleted. It's fairly simple, but I think it's a very interesting prospect from ColdStream. With that, we come to a close of this webinar. As you can already see in our analysis, the 3D printing performs better than the CNC milling case. For the same case setup, we see almost a 20 to 40 Kelvin difference between the two in this particular case. So we do want to encourage you to explore other manufacturing techniques and explore the benefit of generative design. Your manufacturing technique should never hold you back from creating an optimized heatsink or from benefiting from our generative design tool. So please feel free to explore other manufacturing settings and other manufacturing types using ColdStream. As promised, I am going to look at the questions and answer any questions that you may have. So let's look at the questions first. All right. A question that I see here is why is manufacturing settings required for conceptual designs? This is a very good question, actually. So, as everyone knows, conceptual designs are not manufacturable. They're low resolution designs compared to detailed designs, which are manufacturable and are high resolution designs. So, I understand the confusion on why you would need to include manufacturing settings for something that's not going to be manufacturable. Now, to answer this question, you need to understand a little bit about how the optimizer works. So, as you know, the optimizer starts from an empty design and it starts drawing some channels. It goes through the iterative procedure of doing a simulation, seeing how that performs, and then, if it's not matching your constraints and objectives, then it will start changing the design, and then, it will keep doing this iterative procedure till it gets to the best results. Now, the importance of including manufacturing settings for conceptual is because at this stage where it starts drawing the channels, the platform has some information on what kind of channels are applicable. So, for example, because the conceptual is, an estimate of how the performance will be. If, for example, you are going to, use sheet metal manufacturing, or some kind of stamping or deep drawing, then it's important that the channels are also within that range. It makes no sense for you to think about the performance of a 2D manufactured heatsink and the optimizer to give you a performance of 3D shapes or 3D channels. So this is why it's very important to include the manufacturing settings. So the software can create channels that are still within your expectations, still within what you're looking to achieve. So even though it's a first estimation, even though it's not manufacturable, you actually have an accurate representation of how your design could be, how the performance could be, how and how the design could look like. Because without that, you're kind of giving. I mean, without that, it's not possible for you to understand if this estimated performance is very much in line with what you're looking for. I hope that that clearly explains the answer to the question. But if you have any doubts, please feel free to write to me or ask in the chat box again. Let's move on to the next question. All right. So, is the manufacturing type enough? I'm not sure if I understood the question correctly, but I believe you're asking if it's okay to just give the manufacturing type and no settings. In that case, I do want to explain that no, it's not enough, because when you give the manufacturing type, of course, you give the software an indication of how the channels need to be created. But again, it's very similar to the previous question. When you give manufacturing settings, you're very clearly defining the size of your channels, how you know, in certain cases you're also giving like the bending radiuses and angles and things like that, so you're really giving particular values that will help you manufacture this case later. So without that and only a manufacturing type, maybe the optimizer starts creating channels for 5 mm, but you're looking to manufacture them with 2 mm. So it makes no sense if the drill bit or the in case of CNC milling, the mill size that you're going for is 2 mm and your results are all in 5 mm, because then you'll have to do a lot of manual work to correct it. But even then, you're not completely sure if the performance can be improved or not. So it's always best to give the accurate settings, talk to your manufacturer, talk to your suppliers, discuss it with them, and give accurate manufacturing settings to really reap the benefit of ColdStream as a tool. Because without these settings, uh, you will lose out on manufacturability. So to reap the benefits, I highly suggest talking to your manufacturer or your supplier and then giving the right manufacturing settings on the ColdStream platform. All right, next question, perhaps. Is 3D printing always better thermally? Okay, that's also a good question. In this particular case, it was. It's possible that with a different case setup or with other manufacturing techniques or different applications, maybe it's better, maybe it's not. We are not here to vouch for and say that you need to only use additive manufacturing in your heat sinks. What we're trying to show you here is that there is a possibility to use other manufacturing techniques and also explore them for your heatsink. And with ColdStream, we just make that a lot easier compared to how it is done conventionally. Excuse me. And compared to how it's done conventionally. What you get, of course, other factors also play in choosing a manufacturing, a manufacturing technique. There can be cost factors. There can be the fact that you need to mass produce it. There can be the fact that some kind of technique is just not applicable because of the material. So there are different situations, and we're not one to tell you, or we're not one to proclaim one size fits all. So explore, see what really befits you and what benefits your application and your case, and then you can make a choice. Of course, we're always there to assist you if you have any questions, but in totality, the answer is no. It's not always the case. You should explore it and see what is applicable for your case and what your application as well. All right. Let's look at other questions. Okay. Select how do I know this is the right manufacturing setting? Yeah, okay. So the manufacturing type is selected in the design region, but selecting the appropriate manufacturing settings, even we cannot tell you that, okay, this is the right manufacturing setting you can go for, because it's something that depends on your company as well as your supplier and manufacturers as well. So I recommend talking to them. But of course, there's always that question of, okay, I'm not sure if this is the right feature size that I want. Maybe your manufacturers and suppliers are more flexible and they're like, yeah, any of these settings will work for us. You can ask us for like example settings. You will also find them in your library, and you can make you can make a choice of those example settings. But you can also maybe make a choice of your minimal feature size and see how your case responds to that as well. As part of engineering support, we will be able to help you with making these choices and making more realistic choices. So if that is something that is applicable to you, please feel free to ask for engineering support, and we will be able to bring our expertise to give you the right kind of feedback and assist you in making these choices as well. So that is possible from our end if you're looking to if you're looking for assistance in that on that side. Um, all right. I think there are a few more questions, but unfortunately, I don't think I will have the time to answer all of those questions. I will make sure to reach out to everybody who's asked questions. I will email you with answers, and if you have any other questions and it comes up later, please feel free to email me, and I will get back to you as soon as possible. On the other hand, you can, if you're already an existing client, you know that you can use the ColdStream support channel by clicking on the help button on the ColdStream platform. You can simply contact support and ask your questions there as well, and we will get back to you to respond and answer to all your questions. I think this would be the end of the webinar. Thank you very much for participating. I hope you've understood more about manufacturing settings and how that influences generative design. I hope it was very clear how to include the manufacturing settings and how to explore these manufacturing types as part of your case setup and your application. Um, please feel free to ask any questions and reach out to us via the website or the support platform or by email. I hope to see you at the next webinar. Have a really nice day, and thank you very much.